Okay, so this example is we try to learn the tributary area. We know that what tributary area is. Common sense. Under the uniform load on the slab, for example, like this, right? Assume 1 pound per square foot is uniformly loaded on this slab. Tell me how much forces has to go each column? How much? Yeah. Then what is that? Look at the dimensions. Yes. Right. That's a common sense, right? Uniform load has to go because they are all symmetric. So each quadrant area, uniform load has to go to each column, right? So obviously 24 by 24 divided by 4, right? We'll check it. So let's see. Let's see. This model has a live load 1, or 1 pound per, right? So what you can do, this model, I think is always you could click it, means it's slab, right? See that's one shell element selected, right click, you can open the slab information. There are 3 tabs: geometry, assignment, load. I just looking at the load. We have a unit load cases. It has a 1 PSF, pound per square foot. So how are you gonna know it? Go to define, check load pattern. You see that only 1 unit load pattern, right? Other it types others 0 self-weight multiplier. So this is officially intentionally I try to make it. I'm gonna run the model. What I try to show you how ETABS understand, right? Our order. Basically, we are make order. Hey ETABS, why don't you analyze it based upon current, right? Geometry. Yes.
Did you get to the slide information?
Which information?
The slab information.
Slab information, right click. Select and right click. Hold on. Where is my cursor? Right click. This is over. Select and right click. So here, right? I'm selecting, right? Right click. So right click here, slab information, a dialog box is pop out, right? I think it's probably similar also appear these days. It works like this similarly because this is all information model. Beam similar. Beam and all 3D model, 3D software should have their own some information about member or material or something like that. But this is more ETABS. You found it? Huh? You found it? No. Why? Right click. Huh? Or can you write the model? Don't tell me it's something. Okay, there's no excuse. I don't take any excuse. Okay, this example, knowing is things. I think if you know this, your life is much easier. But if you don't know, yeah, it's miserable. Because this is so common sense. There will be some, but because when you run the model, right, automatically you lock. And ETABS show the output mode. This is output mode. It doesn't allow because it's showing displacement, right? So same thing. I'll show you. So let me unlock and show you. So this model I unlock, right? And then I'm just analyze it by clicking run analysis, right? Or analyze here, right? So I'm just run this model, and automatically they analyze it and put this mode. Let's see, because I have only 1 load cases here. Displacement live. Oh, this is maybe not. I didn't change the name. Probably supposed to be. I may have to change the name. Unit. Yeah, this is unit load basically. I didn't change the name. So this is basically unit 1 PSF loading and show me the displacement,
right? So under the current state, this is a locked output mode. They're showing it. In order to select and show something, you need to go here, click show undeformed shape, F4 key, right? Click it. Right? Remember that, because always you likely forget, but something doesn't work, then you maybe have to unlock. Click this, put it in the unconfigure mode. So we have this, right? So now what we're gonna do is we're gonna check the reactions, column reaction. So I think ETABS is more billing oriented. So I'm gonna click this arrow button to go down, right? You click this is going, you can just go up and down along the floor. So I click go down, so this is bottom of the column. So what I want to do is I want to check this reaction based upon 1 PSF of a uniform load. So what should it be? 24 by 24 divided by 4, right? Do you have a calculator? Or Excel? Excel, oh, calculator. 24 times 24 divided by 4. Wait a minute. Huh? 144? Let's check it out. Okay, reaction here. You see the reaction icon? Or everything is in display menu. Display menu, right? So here the force diagram here support spring. Shortcut is F7. Basically, this is we have a shortcut here. So we're gonna select. This is unit load, but I didn't change the name. So what we're gonna do, we check the vertical component. Let's click and see what you have. Oh, oh. This graphing mode is little upward. Okay, 144. Do you see that? 144, 144, 144. Right? Right? This is common sense. Right? The thing is, we need to, what is it called? Calibrate your knowledge, your understanding to how the way the finite element software works internally. You need to understand how. Then maybe, yeah, we need to speak same language. It's finite element, yes, language.
How do you change the units after we finish it?
Okay. Let's see. So because this, if you want to change the unit here, change the unit.
Yeah, imagine that we already finished the whole design.
Yeah.
And we just wanted to share to the customer because they want
metric. Okay. Here you can change it. Okay. Let's see. Here pounds. You maybe want to change the kilonewton, Newton, right? Newton.
Even after we finish the whole thing.
Yeah. See, this is only output mode, but internally everything is done with imperial. When if you want to print out some output, you need to change the unit. So here, this is Newton, right? But here are things, don't mix it because you're gonna make a lot of mistakes. Sometimes rounding error is quite sometimes crazy because 25.4 millimeter, 0.4 millimeter, okay, 1 millimeter. But if you're adding, right?
Yeah, that's right.
Sometimes you're gonna end up with a gap. Construction kind of tolerance is happening. So I encourage to, so any job, an imperial job, always be a start to end using imperial. For metric, start from metric. So because if you convert at some degrees, you're gonna have always rounding error, right? So unit, good question. So but output, you could change the unit here. But the one thing is yes, that's a common sense, right? So now we're gonna talk about other stuff for people. So this is Tributary base, right? Right? This one is very simple. Now let's look at it other, because you need to at least understand Here. Now, how about this? How about this? Okay, wait a minute. Okay, now I'm going to put the column in here. How can you calculate the tributary? Right? Same method, same idea. Okay, this is support point, right? You can simply you need to use some general sense. How we can briefly define the tributary for this column. Based on this, you're gonna draw the center line, right? Probably you can use center line approximation loading, approximation line, and then calculate just traped areas, approximate trapped area. So like this, you could draw down some influence stress line, right? So when you draw it, yeah. When you draw it, you could just use a middle span, and somehow you could just approximately draw some you can have some approximate the tributary area, right? So now we're gonna check the reaction. This one, yeah, obviously everything should be same because it obviously symmetric, but this is not symmetric, right? So now what I may be guessing, this guy may be taking more tributary area, and this is a little bit smaller, and this may be second biggest. Then let's see, based upon just the geometry, just understanding. So here, oh, so some of this should be same as all this model, right? Because we 24 by 24, those are total pounds we assign it. 1 PSF pound per square foot times 24 by 24, right? But this will be distributed different way because of trapped area is different. You see that? This is taking more loading, right? Because I pushed the column in, their trapped area, I changed the intentionally trapped area. And each column taking different reaction. The opposite corner has another. So first, second step, this is the most tributary concept you need to get used to. It's about understanding of geometry and support relationships, right? Because gravity load is coming always pointing down. That based upon your support point and geometry relationship, you need to approximately figure out which column is heavy duty than taking more loading than the other. This is second step. You need to build this because we're gonna practice a lot of load paths, right? Because most likely high-rise building is very complex. Column is not always straight down. Slightly move in and out. It's not all column is on the grid. Residential building, I will show you later. It's not going to be on grid, right? Because of program. For commercial building, many cases simple box shape, rectangular shape, but the column is straight down. But still, you can see the JC Morgan Chase on the construction, right? North side of the Grand Central in Manhattan. The column is shifting in and out here, there. Yeah.
What if we have a building that is like rotating as a spiral?
Okay, we'll get into that. I'll bring it later. Those are something I think YouTube I posted, right? Those something the road obviously the road path is the same, but the geometry is slightly different. The column can be sloped or vertical, but walking there are many.
In my understanding,
yeah,
it's just a slab who rotates a little bit so you can.
It's not basically, yeah. The just only slab shape is different every floor. It's basically it's not. You maybe say overall building looks like rotating, but it's a slab geometry.
Yeah.
It is slightly reshaped, right? So that is a good. This is something that you guys have to. But the rotating structure, 10 years ago, nobody were interested. recently, it's kind of trend. Design is basically a subjective trend, right? Like a fashion, right? Architectural industry never, they don't care about rotating the building, but they they are the one designer. They need to sell this design, right? But all day, nobody care about this rotating cool stuff. I want everything is straight. I don't care. Owner doesn't care about fancy new. So especially Manhattan building, look at it. It's ugly looking just straight, right? But like Middle East, there are a lot of stuff is twisting and like this. I'll show you if you're interested. But again, this is something design aspect, right? But it's market driven, owners and the trend, right? But architect, they want to win the project. They during the usual competition, they try to come up with something very radical idea sometimes. Try to attract and win this job, right? This is most like a design competition. Your architect friends gonna do this because they need to first win this job. With this, they may have some reputation and they can grow their business, right? Architect business is much harder than engineer business. Seriously. But what usually happening is, yeah, there's some trend overall globally. There's a big architect company. Anybody know any architect company? Any company you know? No? Any names? SOM? Oh, come on. HNTB has a maybe architectural group. STB, they're most, I'll maybe talk about a little bit. But yeah, SOM, KPF, right? New York, Chicago. Norman Foster Partners? Foster Partners, come on. JP Morgan Chase. Your building. This main designer is Foster Partners, London based. I know. I know somehow this is something kind of big gap. I don't know, civil engineering student we haven't exposed to this building design, but this some degree, some Chicago people usually they really have more knowledge. They care about building design and there's something nice communities, but not you.
But it's hard to talk to the architects because
Talk-
when they propose a
Yeah.
design
Yeah.
to the customer accepts the design, right? And then the architect comes to the engineers.
Yeah.
We say, you need a color right here in the middle.
Yeah, yeah.
And they're like, no, but I don't want that color. I want the entire space like free for everybody.
Yeah.
And you explain to them, if you do that, the building will be like huge price. It will be very expensive.
Yeah.
And that's the fight that you all the time have to with the architect.
To me, this we should. Yeah. Yeah. Okay, this is a good point. Very good point. You're gonna experience every day, even though small or big, right? So that's why my purpose try to educate architect as much as possible first. But some school usually they try to avoid it. Some school professors more care about your designer and creativity and without any binding restriction, they try to encourage to come up with something more rational or more kind of creative approaches, right? If they're given too much restriction, you're gonna come with the same always box building. But still, to me, big development. Okay, small scale, 1-2 story building, maybe okay. But speaking of tall building, 40 story, 60, 100 story building, right? Should be rational. First, any your kind of unusual condition like a column removal, transfer, right? The cost impact is outrageous. Structural behavior is also one thing, but construction impact is crazily outrageous. Owner, they are not billionaire. They usually borrow the money from the bank. It's a part of business investment, right? But they don't want to pay that extra premium because of one non-necessary column removal. If it has a very strong reason, yes, they try to listen the client try to listen, try to respect the architectural vision, right? But if this is something not it's not first priorities, right? Then you don't want to waste money. So first thing is, speaking of long span structure and tall building, structural form is the most important stuff first, right? Most important because obviously it's backbone, right? If you have a crooked backbone, your body is gonna feel pain. Every day my back hurts. You're gonna feel soon. 20, 30 years later, you're gonna say, hey, you're right. You're gonna feel your back pain soon, right? Same thing, building gonna experience those non-necessary stress because gravity load is always going down, obviously. So the thing is, there will be a lot of premium. It could be short-term construction premium or long-term basis. You may end up with sudden not necessary maintenance or something, right? But the it depends on the size and significance of the building overall. But at least we need to guide right way to do this. So thinking procedure. So architects should really have some at least general understanding of structure, which is nature. Obviously, that is part of nature. We learn from nature a lot, right? But you try to go against to the nature, obviously you need to do something more, not necessary. So you need to put a lot of kind of reinforcement here there because it's going against your nature, which is gravity force, lateral force. But anyway, so I also gonna invite you. I'm just coordinating the site, our design architectural design studio visit during the October, middle of October. We're gonna visit their studio. We're gonna have a talk in general, structural 101 session. You guys are gonna sit with the architectural student, listen where they are in their each design. I think one class I discussed, they are currently designing 14-story residential building, right? Residential building, I probably give it in general kind of approaches. So you guys actually have opportunity to talk, right? And see. Because when I meet with them, they're always asking same thing. They don't have any knowledge. They just learning now. Hey, I want column free space, right? This is one of part of their practice. Without have very strong reason, they just want to have something always. They heard some from where, so they when they come over the building, they want to very skinny column, no beams. I want to have a very high space. Some area I don't want a column, so building looks like floating looking. You're gonna hear a lot, okay? This is kind of beginning of practice. Everybody just been exposed to many stuff, but they haven't got educated long time yet. So when they just practicing design, you're gonna hear a lot of stuff. It doesn't make sense. Sure, right? That's why we need to educate them, guide them. There is some rule of thumb in general, right? Column spacing or some beam size in general. That is, they need to understand. The reason why, at the end of the day, big development is all money. Usually, when architect design team was awarded, they have to some degree try to work within the budget, right? Construction cost. Typically, we as a structural engineer, our works and our effort is mostly a hard cost. Construction code is hard cost. So we should somehow kind of work to meet something that their budget for the hard cost budget, right? But many cases, if you ignore it, you over budget later on. Construction cost over budget like a couple of millions, 10, $20 million, then owners really jeopardizing they may closing their project, shut down the project. Oh, forget it, man. We can't do this. We cannot afford to do this. And shut down. Then the project will be canceled. And you lose job, right? You lose project. Or somehow you need to guide them, right? Structurally, so that we try to eliminate non necessary fat in construction, structural engineering side, so that we try to somebody have to team as a team maintain their own design to meet their construction costs. But usually many big scale job always cost is keep growing. So some CM, typically big project construction management is get involved earlier as a part of a representative owner. They try to manage the cost factor while during the design phase. So they already continuously review the cost impact, right? If they realize some cost is over budget, they need to do some value engineering architecturally, right? Architecture design, not necessarily craziness. They try to somehow smooth, kind of make it simpler, or so that structure we don't do something crazy gymnastic because of that architectural reason. So we need to really kind of massage a lot typically. So going back, that's why I think our role is very important. I know sometimes some architect they just give me the bad language sometimes. Hey, I think software engineer always do this. Why you suggest cannot do this way? Blah 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 blah. Right? My goal is because I know that if I don't educate and also didn't lead them in the right way, it's gonna come back to us and design change. Because architect wants to do something crazy always, right? Because this is their unique design, right? But eventually over budget, then all either project is canceled or they have to redesign. But owner is not gonna pay you. Owner is not gonna pay you redesign. Then because of this, the ego of architectural design, everybody's suffering because the owner is not going to pay for additional service. This is not additional because you agreed to our original requirement that you need to design within the budget, right? Typically big scale job. So this is more realities. And I try to explain a little bit, but I think at this point we try to learn most structurally excellent. We need to understand what would be the most efficient structural system. So we, as a professional, we propose the most well-known track record, like proven method to develop, right, to the client, so that nobody actually picking on this and pointing on this. But there's still always the kind of opportunities whatsoever. But at least I want you to aware of what is typical structural kind of system and practice, construction practice, so that when you propose it, it most likely, yeah, you kind of agree, this is something can be agreed, right? So that you try to minimize any risk, try to minimize the risk to do redesign to meet your budget agreement. Make sense? But I think it's architect and yeah, at this point, sometimes we have a different view. We architect and engineer, we look in from opposite direction. Sometimes, yes, it's always it's kind of different view. Sometimes we fight. No, but this is part of actually procedures that teams should work together. This is really collaboration. I don't want to say this is a fight. This is part of communication, right? Because we both team, we have the same goal, right? Same goal. So next, just hang out with the students and then talk and how they respond. But they need to know that they are primary and project manager. Their influence is much bigger than us in all the place. But anyway, so this is part of your engineering excellence. You need to, right? Here, let's go back. Now, move up. So now, let's put this away. Hey, things, okay, this office space. So I know that I've been practice more than 2 decades. Things more make sense rationally. In order to reach this space, right? You want to provide more regular space.
not this irregular space. How are you going to place your all the furniture in this? Nobody's going to rent this space. I don't want to rent this space. I'd like to rent this space for my office. Make sense? Right? So money. It's a space planning too. Right? Especially with this space, there are many different level of valuations. Ceiling height, right? New building, current market price. Ceiling height actually raise another price, right? And overall amenity space, right? More well open space so that you have a very flexible layout and use of the space. But if this column is like this, right? Obviously, there's so many limitation to place your room or furniture layout, right? But the other way, if you always prefer do this, you end up with all box building, right? Have you visited Hoshin Yard? All the buildings like this, one Vanderbilt, right? Freedom Tower is slightly looks regular, but still they are always right. Kind of changed. They rotate 90 degrees or something like that. But this is another aspect. The owners consider my building. I don't care. I think my first priority is looking good so that people enjoy this building shape. Overall looking is outside. Uh, the geometry and looking is also important. If they believe this is first priority, yeah, the architect have freedom to come up with a more interesting building. Then the building will be well recognized over in the market. They may be getting some high rate, right? Even though some floor may have some retail space, right? Some people still have a preference because this building itself has something their reputation and help to raise their price. But some people said, I don't care. Some owner, I only care about regular space, maximize the rental space. Everything space should be well modulated, right? Then you don't have much actual design aspect. You can embed it, and then likely building is most likely a box. So there are a couple of examples in the Manhattan city, Manhattan. You could take a look at it closely now. But this is beyond our scope, right? This is more owners and architects. Typically, owners go, but architect maybe has to guide them the impact because owner is not a professional. Architect is professional. Okay, market analysis has to guide them, right? So this is not just only design alone. So you need to think about it. The building design and construction is not just only just hardware design. All right, so we just talked about this one and this one, right? Makes sense, right? Common sense. They're simple. Now, how about this? Okay, same thing. Column is instead of square, triangular shape. What's wrong with this? I think I covered it. Total loading should be same, right? Because this area, these two areas eventually cover same this area, 24 by 24. Only difference is this is rectangular shape, aspect ratio is also matter, but this is triangular. Let's see the reaction. Downstairs, move down. You see this? It's not identical, right? This guy is taking a little bit more than this. Since this is a square 24 by 24, you probably will see the non-huge difference, but obviously this is not we want, right? We want this output, right? Common sense, we want this output, right? But how come this one doesn't give us the output we want? Because of this triangular shape. It's finite elements, kind of different type. See that? Let me just
shrink it. Ah, this. Right? So this is a triangular element. Maybe because of triangular shape, internally they have different formula so that uniform load distribution is slightly different than this, or the aspect ratio related. So obviously you don't see different reaction. Now we're talking about one story. If you using this method multiply by 100, the column reaction is quite significant difference, magnitude-wise, right? Here, again, right? Let's say this is about 3.8 pips pound difference. But if this is a real building and 100-story building, this reaction is substantially different. Eventually, if we have to design the pile caisson, that difference is also sometimes lead us wrong way. We maybe end up with the two pile here, one pile there. So what I try to say here, we need to understand the finite elements, what would be the most good approach the right way to use it. There is something fitful, right? Pro and cons. So you need to at least understand. But how do I understand? Because how I know this? How they make their assumption internally? Yeah, this is the one way you need to continue to do this. Small model we call patch model, right? Make this. What if I use it? Will patch give us the same output? What if I did this? Okay, it makes sense because of chart area. So this one method is basically working based upon their meshing. I'll show you. Hold on. Internally, they mesh it. This. So here, shell analysis mesh. I'll turn on. So this is internal mesh, not real physical mesh. Internally, ETABS made this. They internally kind of define this mesh, and based upon this mesh, they distribute the loading. Somehow this one is slightly different because of the shape. You see that? So based upon this structure, internal mesh, they figure out the tributary area and give us the reaction. So this tributary area is one of the hardest. You should really understand in order to build the entire huge model. You need to understand your software, how each element works. No matter how other software, any software you use. Other one is like this. Maybe you can use this. Take this one. So now, what about? Okay, I don't want to create crazy model, but I know this area. Hopefully, we have a high loading, different load, right? Different load. Let's say here one PSF, but here 100. Let me see. What did I assign? Now this change to. This is more now flexibility and in engineering judgment, you need to sometimes use it to create the approximation model enough to simulate the one you're expecting. So for example, this one has one PSF, but I know that architect or owner was something heavy loading on here. Then what is the user's choice, right? The ETABS usually has set it up based upon feedback. You draw the another boundary area element. Could be non-member. Instead, a real structure element. Area like this, and assign additional node. Additional node. So this one has one PSF. This one has a two PSF. Let's check it. So this is, I think, so one click outside, I click, so outside has a 1 PSF, right? And then I click inner one, click this two, a small area has 2 PSF loading. So internally, based upon their machine internal network, they apply 1 PSF outside, 3 PSF inside. So 1 plus 2. This is something ETABS kind of feature they added because we need this a lot. The reason why before without this feature, in order to increase the area here, what kind of choice we have? We'll have to use average. Okay, since this area 2 PSM, 3 PSM, and 1 PSM, do I have to use average area so that we can assign as a big one average uniform load? Or do I have to add some sort of dummy line element and assign as equivalent dummy equivalent line load? What can we do if we don't have this kind of feature, right? Because the building is so big enough, large enough, loading condition might be different a lot, right? Our project, we simplify, assume same loading, but basically this classroom load and corridor load is different. Our design. This is classroom, so maybe 50 PSM is pretty. Corridor is higher, either 80 or 100. 100 by the code, because public traffic is more, right, than room classroom. So design load is different. And you are the one, you need to think about it method, how to assign a property, approximate enough. What is a method? I give you, since ETABS says this, because I think we get them a lot of feedback, so they build this type of feature. Before they didn't have this feature. So I need to use average area and assign. Otherwise you're gonna miss some loading, right? This is something another step. I'm just giving you the because now you need to build this type of. At this point, this is something not engineering mind, just something common sense. How we have a requirement to address the higher load, but how we this because we currently model draw the one big plate. If we don't have this feature, I already explained equivalence somehow. I need to find some the area or using average weight, average uniform loads, or we may have to mesh it. You know, physical mesh, right? And assign this, select this mesh, and assign the 3 PSF here. Select all this outside area, assign 1 PSF. That is another method. You follow that? So this case is I have a big area and I have another small area. It's duplicate, but they recognize it internally, so they don't add their weight, right? But they recognize area load from here and here, so they add it together, But before, if we don't have this feature, this is more ETABS thing, other software might be different. I have to do your machine. Means, I have to draw the more number of area manually and assign, select the area element and assign the proper loading manually. So that was really heck of work and eventually creates bigger model. Computation time is much bigger. It's really not helpful. So current ETABS feature is very beneficial for structural engineer to handle the the modeling and for assigning the loading purpose. Any questions so far? So this is a load check down. I just tried to explain and basically
what for finite element software analysis advanced structural analysis course usually teach the finite elements material, and they call quadrilateral elements. It's quadrilateral element, but I don't care. Just every element, right? Rectangular, triangular, but I think we need to at least aware of their behavior, right? Loads distribution behavior is slightly different. Also, aspect ratio. This case is 1-to-1 ratio versus square, right? But if this is kind of has a different aspect ratio, you may have to pay attention sometime their own behavior and their own characteristics. Okay. So any question about this? It's common sense things, right? At least minimum understand. Okay, loading distribution is based upon geometry of the support layout, but I think we need to really aware of the type of slab elements based upon geometry, square, rectangular versus triangular. But some building, because heavy complex geometry, we sometimes mix it. Because we cannot use always square, you may end up with tons of mesh elements. So sometimes we have to mix and match, but yeah, I want you to just kind of aware of this.